Hello, my name is Naresh Besanazaria and I am going to present on a thread in a Java. My two teammates Harshvardhan Makani and Vishal Rayani is going to join me after some time. Harshvardhan Makani is going to present how to write a program in a Java in a thread, and Vishal Rayani is going to explain what is the practical use of a thread in a Java. Let's start with a thread. What does a thread exactly means? Thread is a single sequential flow for control within a program, or we can say that a thread is an independent path of execution within a program. A single thread program can handle one task at a time. Means if we have a single thread in a one program, so it can handle only one task within the same time. Means at the same time we can handle only one. We can perform one task only. That is not feasible for the modern operating system. We have to go and we must have to go for the multi-threading. For going to multi-threading, we must consider what is a multitasking. Multitasking allows a single process to run in several concurrent threads. Means one process can handle several concurrent threads simultaneously. We can use the CPU resources at the same time. Most modern operating systems support the multitasking. To better understand a thread, let's consider why do we need a thread. We need a thread for a parallel processing, increase response time to the user, utilize the idle CPU time, prioritize the work depending on the priority. Which work do you want to perform based on the priority? Let's consider the example of the web server. The web server listens to the web request and serves it. If the web service does not support the multi-threading, then each requested will get the full web server resources, and each request will be executed at the single time. But the disadvantage of this is when the multiple requests are come to the web server simultaneously, it may not respond quickly and the hang of a web server will be higher. By implementing in the multi-threading environment in the web server can handle a multiple requests simultaneously, thus improving the response time. Life cycle of the thread. Thread can be in one of the 5 states: new state, runnable state, running state, block state, and the terminated state. According to the Sun, in Java, the life cycle of the thread has only 4 states. There is no runnable state. That is, when any thread is created, it goes to the new state. Then the thread is started and it's go to the runnable state. After the runnable, it's go to the block as well as it can go to the terminated state. You will better understand the life cycle of thread by this figure. There is a 5 circle which show the state of the life cycle of the thread, and arrow show the execution of the thread from one state to the other state. The first is a new state. When any thread is created, the thread goes into the new state, and after the thread creation it goes into the runnable state while executing the command start, and after runnable it's go to the run state when the thread is getting into the running state, and you can pause the state or you can put into the sleep mode a state. At that time the thread will be in the non-runnable state, and you can resume a state or you can remove the sleep mode. That time will be thread will be going into the runnable state, and you can exit a thread anytime and it will go to the terminate state. Let's consider each and every thread state in a details. New thread. The thread is in the new state if they created an instance of the thread class, but before the invoking of the start method. Runnable state. The thread in the runnable state after invoking a start method, but the thread schedule cannot be selected into the runnable state. Running state. The thread is in the running state if the thread scheduler has selected it. Non-running state, or we can say that the block state. This is a state when the thread is still alive but currently not eligible to run. Terminated state. A thread is a terminated or a die state when the run method is executed. After this, Harshvardhan Makani is going to continue and he will explain all the Java code and how we can write a program in a Java, and executing this all the threads state, as well as he will show programmatically how can you write each and every state of the thread. Thank you.
Hi, we shall now see how threads are created in Java.
There are two ways to create threads in Java. The first one is by implementing a runnable interface and passing an instance of the class, implementing it to the thread constructor. The another one is by extending a thread class and overriding its run method. We shall see now both these ways in more detail of creating the threads with examples. The first one is to create a thread by implementing a runnable interface. In this, first we implement the run method of runnable interface. This method is where the thread starts, hence all the business logic will come here. Then next, thread object is instantiated. Once the thread object is created, start method is called to start the thread. This start method will call run method, where is the business logic of what is to be done by the thread. An example of creating a thread by implementing runnable interface is, in this example we have two classes. One is test thread and another one is runnable demo. Test thread is our main class and runnable demo will be implementing runnable interface. So when main method will be called from the test thread class, it will be creating two threads, and those threads will be created from the start method of the runnable demo. Start method will create the thread, and after that it will give the execution flow to the run method, where the thread will be running and performing the task. Next up is to create a thread by extending a thread class. In this, first we override the run method available in thread class. This method provides an entry point for the thread, and you will have to put complete business logic inside this method. Once the thread object is created, start it by calling start method, which executes a call to return method. An example of creating a thread by extending a thread class is, in this example we have two classes. One is thread demo and another is test thread. Test thread is our main class and thread demo will be extending thread class. Thread demo will be overriding run and the start method from the thread class. And once main method is called of test thread class, thread 1 and thread 2, threads will be created. These threads will be creating by first calling the start method of the thread demo class. Start method will create the thread, and then the business logic will be performed by the run method, which will be called by the start method itself. The run method will be executing all the business logic, and after that the thread will be finishing. We shall now take a look at some of the thread methods. Following is the list of important methods that are invoked on a particular thread object. First, public void start. This starts the thread in a separate path of execution, then invokes the run method on the thread object. Public void run. If the thread object was instantiated using a separate runnable target, the run method is invoked on that runnable object. Public final void setName. Changes the name of the thread object. There is also a getName method for retrieving the name. Public final void setPriority. Sets the priority of the thread object. The possible values are between 1 and 10. Public final void setDaemon. A parameter of true denotes the thread as a daemon thread. Public final void join. The current thread invokes this method on a second thread, causing the current thread to block until the second thread terminates or the specified number of milliseconds passes. Public void interrupt. Interrupts the thread, causing it to continue execution if it was blocked for any reason. Public final boolean is alive. Returns true if the thread is alive, which is at any time after the thread has been started but before it runs into completion. An example of creating threads in both the ways and some of the methods that we just went through. In this example we have three classes: thread class demo, display message, and guess a number. Thread class demo is our main class. Display message will be implementing runnable interface. Guess a number is extending thread class. When main method will be called of the thread class demo, 4 threads will be created. The first two will be created by the display message and the next two will be created by a guess a number. In this example we have also used the methods that we previously saw. Some of them are like setDaemon, setName, and setPriority. The output will be something like this.
Hello, I am Vishal. Now we are at the last part of the presentation, and here we are going to talk about thread applications, how the thread application works, what is the multi-threading and advantages of the multi-threading, thread synchronization, and the daemon threads. So let's start with the thread applications. It is at operating system level, application level, bottom line. Suppose in a mobile phone you are watching a video on YouTube and at the same time you are chatting with your friends, so it is a multitasking. And at the application level it is multi-threading, like multiple operations perform at the same time. We are going to discuss multi-threading later on the slides. Another type is the bottom line, like a concurrency of the processes. Suppose you are in a library and one of your friend is printing some documents on printer A, and at the same time you also give print to that printer A. Then it sends a wait signal to you, and after printing your friend's documents you are able to print. So it is a concurrency of processes. So by using thread, multiple applications run concurrently. Multiple applications means multiple processes run on a computer via thread, like in computer while listening to music and seeing some photographs you are mailing to some of your friends. So it is applications of thread. Now we are going to talk about advantages of multi-threading. First one is it doesn't block the user because threads are independent and you can perform multiple operations at the same time. Second advantage is you can perform many operations together, so it saves the time. Another one is threads are independent, so it doesn't affect other threads. Suppose an exceptions occur in a single thread, and suppose a fault occur in a single thread, so it doesn't affect the another threads and whole system is working. So it is going to very useful for the operating systems. This is a diagram of multi-threaded program. There is a main thread and there is a multiple threads are running under the main threads. Thread A, B or C are running under the main threads, and during the processes threads may switch or exchange the data or the results. So here we understand previous diagram with an example. In an Android application, main thread, like a UI thread, is not overloaded for computation. Rather, a new thread is created for it. For example, thread A is querying to database and fetch some results from database. Another thread B is suppose allotted for the printing a prime number between 1 to 200, and thread C is doing Google. So these all threads are running at the same time, saving the time for the operating systems and give results to main thread. So here we are going to talk about thread synchronizations by monitors methods. In the monitors object with the synchronized methods, any object can be a monitor. A method declares as a synchronized, like the format is public synchronized integer my method integer x. Here only one thread can execute a synchronized method at a time, like resource obtaining the lock, and after getting the resources it releases the object. So it is a synchronized method, and if multiple synchronized methods declared, only one may be active. Java also has synchronized blocks of code. Thread may decide it cannot proceed. It may voluntarily or automatically call wait while accessing a synchronized methods. It removes thread from contention for monitored object and processor. So first thread synchronization call, it is always going to enter in the wait condition. So thread is in a waiting state. Suppose at the same time other threads try to enter the monitor object. Suppose condition first thread needs has now been met, so it can call notify to tell a single thread which is in a waiting state. So it is going to enter the ready state. If there are multiple threads in a waiting state, so it use the notify all, and so all other threads are ready to enter in the ready state. Here I am going to introduce daemon threads. Daemon threads that run for benefit of other threads. Example is garbage collector. It reclaims the memory occupied by the objects that are no longer in use of program. So other threads can utilize that resources. Other one is daemon threads run in background. It maximizes CPU utilization. So it uses processor time that is going to be waste. Unlike the normal threads, it does not prevent a program from terminating. There are only daemon threads remain in the program can exit. It can be implemented such as void set daemon 2, and it must designate a thread daemon before start called, and the method is called like method boolean is daemon. If it returns true, a thread is daemon thread. Thank you.